Hi guys, and welcome to Module 11. I wanted to start off with this bell word question. A taxi charges a flat fee of $4 plus $4.25 per mile. How much is it going to cost to travel 7.1 miles? So if you remember, this was a two-step problem in which we had to first calculate how much the taxi would charge us just to travel the miles. And so we're going to take 425 per mile times 7.1 miles. I'm going to pretend like the decimals are not there, and I'll take care of them at the end. 1 times 5 is 5, 1 times 2 is 2, 1 times 4 is 4. I'm done with that ones place. 7 times 5 is 35, 7 times 2 is 14, 15, 16, 17, plus 1, that's 28, 29. And so it looks like we have the digits 30175. We're going to move the decimal point over 1, 2, 3 times over. And so we have to think, is the taxi going to charge us $30.17 or $30.18 based on that number 5? Remember, we always round to the hundredths place when we're talking about money, and this 5 or more means raise the score. So we're looking at $30.18 for the trip, but we can't forget the $4 flat fee. That's a one-time fee. Make sure we line up our decimal points properly, and so the answer here should be $34.18. This slide just reviews the difference between an expression versus an equation. The expression does not have an equal sign, where an equation has the word equal in it, and that's an easy way to remember that the equation does have an equal sign. When determining whether the given value is a solution of the equation, we would plug in the value of x. The equation here is x plus 9 equals 15, where x equals 6. So we plug in 6 and substitute it for x. 6 plus 9, is that equal to 15? 15 is on both sides of the equal sign, and so this is a solution of the equation. I asked you guys to be very careful when given situations like this, because here they give us y divided by 4 equals 32, where y equals 8. So instantly we want to think about, well, 8, 4, 32, they're all in the same fact family. But if you actually do the calculation, 8 divided by 4 is equal to 2, and that is not equal to 32. So this is not a solution of the equation. This slide allowed us to practice writing an equation and checking its solutions. So in this example, Sarah used a gift card to buy $47 worth of groceries. Now she has $18 left on her gift card. We need to write an equation to represent the situation, and then use our equation to determine whether Sarah had $65 or $59 on the gift card before buying the groceries. So what we would do here is, the first thing we would do is write the equation to fit this situation. I don't know what I started with. That would be my x. I do know that I spent $47, so minus 47. And I do also know that I had $18 left over. So my equation would be the money that I started with, x, minus $47 worth of groceries, equals $18 left. In order to solve for x, I'm going to do the inverse operation of minus, which is plus. So I'm going to do plus 47 on both sides. That way I can cancel this out and solve for x. X equals $65, and so my answer is Sarah had $65 on the gift card before buying groceries. In this slide, we review solving the equation using subtraction to solve this equation. So if the equation was a plus 15 equals 26, We're going to solve by doing the inverse. So we do minus 15. What we do to one side of the equation, we do to the other. So A equals 11. We're going to then check, plug in 11 for A. 11 plus 15 equals 26. So that worked. And then when we graph it, we're just going to make A equals 11, and we graph that on the number line. So let's go ahead and try this one together. If we have to solve the equation 5 equals W plus 1 and 5/10. The only thing that's different here is they switched the commutative property. They just gave me the equal on the other side. That's not going to change anything. And they also gave me a decimal to work with. Well, we can do that. That's fine. Our equation is 5 equals W plus 1 and 5/10. In order to solve for W, we're going to have to do the inverse operation, which is minus. So we're going to do minus 1 and 5/10 on both sides. That way we can cancel that out and solve for W. I asked you to please be careful when subtracting a whole number and a decimal, and make sure that you go ahead and set it up that way. That way you can line up your decimal points and you don't get confused. You can't take 5 from 0, so the 5 becomes a 4. This is 10 minus 5 is 5. Make sure you line up your decimal points like a soldier. 4 minus 1 is 3, and so W is 3 and 5/10. When we graph that, we're going to go over to the positive side of the number line, and we're going to go right in between 3 and 4. And there is my W, which is equal to 3 and 5/10. Similarly, when asked to solve the equation y minus 21 equals 18, in order to solve for y, we're going to do the inverse operation of minus, which is plus 21 on both sides of the equal sign. Y equals 39, and then we're going to plug in 39 for y and make sure that that is a solution. 39 minus 21 is equal to 18, and so that did work. When we graph the solution on the number line, we are going to graph y equals 39. Now for this slide, we're asked to solve the equation h minus a half equals 3/4. And so we're going to have to practice here adding fractions with unlike denominators. And so I'm going to go ahead and rewrite this equation. H minus a half equals 3/4. We talked about how in order to solve for h, we're going to have to do the inverse, and so we're going to have to do plus a half. What we do to one side of the equal sign, we have to do to the other, and so that way we can cancel that out and solve for h. H equals, and we're going to have to find the least common denominator here, which is 4. Everything here is going to remain the same because this is times 1. And here this is times 2, so this becomes 2/4. So 3/4 plus 2/4 is the same as 5/4. And if we're asked to graph that on the number line, that is the same as 1 and 1/4 or 1.25. And so when we graph that, we're going to go right between the 1.5, which would be between the 1 and the 1.5, so this would be 1.25, and that would be h. In this slide, we talked about the difference between complementary and supplementary angles, and we talked about how we were going to remember that. In our notes, we should have complementary angles. We remember them by the C in complementary, just like the C in corner, which is going to be a 90-degree angle. So corner, complementary, C and C. We also remember that supplementary angles are the ones that equal a full 180 degrees, and the way we remember that is S for supplementary and S for straight. And so we modeled this with our arms as well, but the best way to remember complementary versus supplementary is complementary are your corner ones, they're 90 degrees. Supplementary are your straight ones that are a full 180 degrees. And so in this slide, we're asked to find the measure of the unknown angle. We notice here that the unknown angle, which is x, plus 60 is going to give me a full 180 degrees. And so what I'm looking for is what is the measure of x? So with my equation, x plus 60 equals 180. I'm going to do the inverse of plus, which is minus 60 on both sides. That cancels this out, leaving me to solve for x equals 120 degrees, which makes sense. If I plug in 120 degrees here plus the 80 degrees, plus the 60 degrees here, that gives me a full straight 180 degrees. When asked to write and solve an equation to find the complement of an angle that measures 42 degrees, complement comes from the word complementary angle, which we know is the corner one. So we're looking for angle measures of 90 degrees. So the expression that we can write is x plus 42 equals 90 degrees. And so to solve for x, we're going to have to do the inverse operation of plus, which is minus 42 on both sides. That way I can cancel and solve for x. I can't take 2 from 0. The 9 becomes an 8. That's 10 minus 2 is 8. And 8 minus 4 is 4. So the answer here is 48 degrees. In this slide, we're going to practice writing real-world problems for a given equation. Joshua wants to buy his mother flowers and a card for Mother's Day. Joshua has $25 to spend and selects roses for $21.79. How much can he spend on a card? So the flowers are $21.79. The card, we don't know how much he can spend on a card. That's our variable. That's our X. We do know that he has a total of $25 that he can spend. So I'm going to rewrite this equation, $21.79, which is the cost of the roses, plus X, which is how much he can spend on the card, equals the total $25 that he has. And I'm going to set that up as a decimal because I know that I'm going to have to do the inverse. So I'm going to have to do minus $21.79 on both sides so that I can solve for X. And that way that can cancel out and x equals. I'm going to have to practice here my regrouping. I can't take 9 from 0. So I borrow from next door. I can't, but I tried. So once I borrow from him, he becomes a 9 because I attempted to borrow from him. So 10 minus 9 is 1. 9 minus 7 is 2. Line up my decimal points. 4 minus 1 is 3. So Joshua can spend $3.21 on a card. Now when solving an equation involving multiplication, we're going to do the inverse to solve for the variables. So in this equation, 9a equals 54. We're going to divide both sides by 9 so that we can solve for a. A in this case, 54 divided by 9 is 6. When we check, 9 times 6 is 54, and so we graph that, and A equals 6. So we can go ahead and practice this one together. We have 3x equals 21. We're going to solve for x, and we're going to graph the solution on the number line. So 3x equals 21. This is an equation involving multiplication. So to solve for x, we're going to do the inverse operation, which is divide both sides by 3, so that we can cancel and solve for x. X equals 21 divided by 3 is 7, and when we graph that, x equals 7 on the number line. When solving an equation that contains division, we're going to solve by doing the inverse operation, which is multiplying both sides of the equation by the same number. So in this example, x divided by 5 equals 10, we are trying to solve for x. Since this is a division, we're going to do the inverse or the opposite. So we're going to multiply both sides by 5. That way we can solve for x equals 10 times 5, which is 50. When we check it, we plug in 50 divided by 5. Does that equal 10? Yes, and so we can graph it. X equals 50. So this is another example of solving for r. 15 equals r divided by 2. In order to solve for r, we're going to do the inverse or the opposite of division. We're going to multiply times 2 on both sides to solve for r. R equals 30. When we check it, does 30 divided by 2 equals 15? Yes, and so we can graph r equals 30. In Module 11, we also learn how to graph solutions of inequalities. And so if we have a variable that's less than or equal to -3, we're gonna go ahead and create a number line. I'm going to put 0 here, and I'm going to put my positive numbers on the right-hand side. I'm going to put my negative numbers on the left-hand side. Now, this is telling me less than or equal to -3. So automatically, I'm going to go to -3 on my number line. This less than or equal to means that I'm going to have a closed circle because my answer could include -3. Y is going to be less than or equal to -3. So all the numbers that are less than -3 are on the left-hand side of my number line. For this slide, we have to write an inequality that represents the phrase, the sum of y and 2 is greater than 5. So we're going to start there. We're going to start by writing the inequality that shows the sum of y, sum means plus, so the sum of y and 2 is greater than 5. We're going to draw a graph to represent the inequality. So we're going to solve for y. And we're going to solve it the same way as we would an equation. This is an inequality because our answers could be more than one number, could represent more than one number. So in order to solve for y, we're going to do -2 on both sides. And that way we can solve for y is going to be greater than 3. Now, because my answer does not include 3, it's not greater than or equal to 3, it's just greater than 3. It's going to be a closed circle on 3, and so my answer is going to be an open circle with the arrow going to numbers greater than 3. So if I plug in any number greater than 3 to this inequality, that would make a true solution. This concludes our review on Module 11. Any questions, please feel free to ask.